Welcome. Today we're going to talk about Meta-MCP, which is a way to deploy agent functionality as MCP tools, which should be pretty straightforward, but we'll see. So first of all, let's talk about TsAgent. That's the context that we're going to use when we talk about the agents we're building. It's the tools we're going to demonstrate. So it's our TypeScript open source platform for building and running agents. It's a whole ecosystem of different packages, including an Agent Foundry desktop application that you can use to build no-code agents, a CLI, some A-to-A servers and orchestrators, and our TypeScript agent builder and runner APIs. So everything I'm going to show you demonstrated via our desktop app. You can also do via CLI, or you can do directly by calling APIs and embedded in your own applications. It has built-in context management with references and rules, and it has MCP support to support importing external tools, and it works with every LLM provider, cloud hosted or local. So it's basically an agent platform that does all the things that agent platforms do. So we started with this question: does your MCP server need an agent? And we've seen a bunch of solutions lately, especially just in the last few weeks, of essentially semantic agentic layers being added into MCP servers or gateways. So we've seen that with the StackLock tool optimizer. Docker has this tool composition feature, and they recently released another feature that's kind of like the tool optimizer. We've seen semantic tool selection from AWS Agent Core, where they're able to take giant collections of thousands of tools and use a semantic search to return the proper tools to clients without giving them access to all the tools. And even the GitHub MCP server on a sort of a smaller scale, it's an MCP server that's sort of known for having a lot of tools. Like I think it has around 100 tools. And they've done a few things with tool sets and other ways to trim those back, but they have a new feature called dynamic tool discovery, where you essentially just the MCP server exports a tool, which is sort of tell me what you want to do, and it gives you back the set of appropriate tools, which you can then call. So the thing all these have in common is they've implemented this sort of semantic or agentic layer inside of an MCP server. And that kind of got me thinking about, well, what if you could deploy an agent as an MCP server, or agent functionality as an MCP server? And we've done some work with A-to-A and some other things that are kind of similar to that. But does that unlock some other new use cases? So we'll give you a quick description of what we did and why we think that it does. So first of all, when we deploy an agent with TsAgent, the general idea is you go build an agent, you give it lots of context and lots of tools, and you basically make it smart and teach it how to do things. And then what do you do with that agent once you've built it? So we have agent modes within TsAgent. The default mode is interactive, so that's just a normal chat agent. That could be an agent that you literally just chat back and forth with, like ChatGPT, or it could be something that you call from code in that similar kind of chat API where you send a message and you get a response. And there can be tool calls and all kinds of other things going on in there. When we built in our A-to-A support for agent to agent, we added another mode called autonomous. So this is similar to the chat mode, except it's essentially you're going to make one call in, you're going to get one response back. That call will not be able to use any tooling that requires user approval because it knows it's a headless autonomous agent. And the agent exports skills. So these are basically ways to explain to the calling agent what the called agent is capable of doing. And then we added a new feature, which is what we're going to talk about today, called Tools Mode. And so Tools Mode allows you to deploy your agent as an MCP server with exported tools. And I'll show you what that means in a second. So why would you want to deploy agents as MCP server tools when we already have A-to-A and ACP? We already have ways for agents to talk to other agents. And there's a couple of reasons. One is sort of practical, which is that A-to-A and ACP aren't really not widely supported, especially in desktop agents and other like coding agents and things that you actually are using now. All those things support MCP. Very few of them support A-to-A or ACP. And the second reason is in A-to-A, the agent skills are not as well structured and reliably called as MCP tools. They're designed to work a little bit differently and in a way that I think makes them more of a challenge in some cases. So I'm going to briefly just step into that for people who maybe aren't familiar. So A-to-A skills and MCP tools are pretty similar. The way they're defined is almost exactly the same. So they're basically a collection of entities where you have a name, a description, and a set of parameters. And they allow the calling agent to understand the capabilities of a server. So whether that's an A-to-A agent or whether that's an MCP server, the general idea is you have this list of tools or skills that say, hey, this is the name of a skill or tool, here's what it does, and here's the parameters I need, and here's maybe what you're going to get back as an answer. The difference is that with A-to-A skills, the agent doesn't invoke the skill directly or pass structured parameters. It just passes natural language. So the agent, basically, the calling agent says, oh, I see you have a skill that you know how to book a flight and you need some information to book that flight. So it just sends a natural language prompt to the other agent to tell it to book a flight. And then the other agent has to understand the intent based on the natural language that, oh, this is somebody who's trying to book a flight. And that might be complicated if there's a whole bunch of skills in this agent. And then it has to parse the parameters out of the natural language that it wanted to get in the first place to go do its job. With MCP tooling, it's a lot simpler because the calling agent just makes a specific tool call. They're like, hey, I want to do this specific tool by name, and here are the parameters you asked for in exactly the structure that you asked for them, and I have a specific expectation as to what I'm going to get back as a result. So the real difference between A to A and MCP is A to A is basically just natural language. I'm going to give you a skill definition, and you're just going to tell me in natural language what you want me to do. And MCP is essentially I'm going to give you that definition, and you're going to make a tool call, like a specific tool call. And that's kind of important in the way that we implemented it and the way that we map it. So I gave a much longer explanation to this to a friend of mine over a couple of beers. And at the end of the whole thing, he said, oh, so you're just exposing agent skills as MCP tools. And I'm like, yeah, I should have just said that. Yes, that's exactly what it is. We found a way to take agent skills and expose them as MCP tools. So let's talk about the agent tool export workflow. So in this new tools mode, the general idea is like as if you're building an A to A agent or really any agent, you start out by just building your expert agent. So you create a new agent, you create references and rules, you load it up with tools, and you basically build in the expertise that the agent's going to use to solve whatever problem you wanted to solve. And then you can just chat with it, right? So we have an interactive chat mode. You can try different models out, different model parameters and settings, and basically just chat with your agent that you built and assess whether or not it seems like it's smart enough and knows how to do the things you want it to know how to do. And then once you're sort of at that point where you're like, okay, I've created an agent that's an expert in whatever, then you can start thinking about what specific skills and tools you would want that agent to be able to export. What are the things you want it to be able to do? And then you can define those skills as exported agent tools. And I'll show you how that works in a second. Then within the TsAgent UX, you can actually validate those exported agent tools. It'll present you a user interface where you can tell it which tool you want to run, provide the parameters that tool would ask for from an agent, and it'll go generate the response. And you can see the full response generation, what context it used, intermediate tool calling, all that kind of stuff. So you can really test and validate that these exported agent tools work exactly the way you think they're going to work before you deploy them. And then once you've done that, you can install the Meta-MCP server into the MCP client of your choice and point it at your agent. So you can install this into Cloud Code or Cursor or whatever. And now that client will be able to use those tools exported by your agent. So that's basically the workflow. So what does an exported tool look like? It looks a lot like a skill, and it looks a lot like an MCP tool. It has a name, a description, and a set of parameters. And internally, those are sort of formulated in JSON schema the same exact way that MCP defines parameters. And it has the same set of values. So you can have, strings, numbers, you can have ranges. There's, all the things that you would do if you were writing an MCP tool in code. You can all do that all through the UX as you're defining these exported tool parameters. And then the key difference is the last piece of it is it has a prompt. So the way this works is pretty simple. It's sort of amazing that it works as well as it does, given how simple it is. But essentially what happens is when an agent goes to call this tool, to call the book flight tool, for example, it's going to pass in these departure and destination strings. And all the agent's going to do, all the caller of the agent's going to do is basically it's going to replace these tokens in the prompt with the values of the parameters, and then it's going to send this prompt to your agent. So that's sort of the magic of it. That's all that's really happening is we're basically describing a way to form a prompt that the agent can then apply as a skill and return the answer. So Meta-MCP is the sort of magic middle piece that makes all this work. It's an MCP server that you can install like any other MCP server. And what it does is it essentially connects your agent to your agent exported tools to a client as MCP tools. So you install it just like any other one. This is a standard IO. We're just doing npx, and we're running the published version of TsAgent Meta-MCP. And the only parameter it takes is the agent that you want to point it at. So like you've gone in and created this agent called TsAgent. And now you want to expose its exported tools to, say, Cloud Code, then this is what you dump into Cloud Code. You just say, hey, let's go run this Meta-MCP server on top of this agent. So let's see what that looks like in a demo. This will be fun. We're going to do two demos. We're going to have one where we've already created an expert on the ToolVault product, an agent. It's called TVault. And it has a couple of exported tools, ToolVault get status and get server info. And then we have another use case, which is an MCP optimizer example where we take a large collection of tools and we build optimized access to that. So we have an agent called optimizer, and it has an exported tool called find tool and one called call tool. So they're both pretty straightforward. So let's start out with the T-Vault. So I have a couple of agents running. The T-Vault's in light mode and the other one's in dark mode, so I can tell them apart. And let's just go through quickly what we have here. So we have a single reference called ToolVault status, and this essentially explains how to tell where ToolVault is installed and whether it's running. So it's just a little bit of text description that explains where to find this file, how to parse it, what it means, how to get the status. So pretty straightforward. I just copied and pasted this out of some docs that I had laying around. So this is not something that an agent, by just looking at the source code, would easily be able to sort of work out, but it is something with a little bit of textual help. We can kind of guide it how to figure that out. We don't have any rules, and we have a pretty small tool set. We basically just have the fetch tool so they can talk to the internet and a file system tool. And that's kind of all there is. So let's go look at the tools that we built. So first of all, we go into agent info, and this is the same way we would define an A-to-A agent or any other agent, except now we have this new agent mode. So we used to have interactive and autonomous, and now we have a tools mode. So for tool agents exposing MCP servers with dynamically defined tools. And when we select tools mode, we're going to have this exported tools menu item right underneath that, and this will show us our tools. So these are, I'm not going to show you how you build these, but it's just pretty simple point and click. You don't have to write any code. It's pretty straightforward. So I built a tool called ToolVault status. Its description is determine if ToolVault is running, including API port and gateway port. So this is what the agent will see as an MCP tool description. And then I have this prompt template. So this doesn't take any parameters. It just says determine if ToolVault is running, including the API port and gateway port. Same exact thing as a description. So what happens when you call this is it's just literally going to send this exact prompt to the agent that we've defined that that again has that reference and has those tools, and it's going to answer that question. And then we have one that's a little more complicated where we have get server info. So this is about a server that's installed in ToolVault, an MCP server installed in ToolVault. So it's get information about an MCP server installed in ToolVault. It takes a single parameter, which is server name, which is the name of the server. And then it has a little bit more complicated of a prompt. It's like determine if ToolVault is running and on what port, connect to the API get servers endpoint to get a list of servers, find the server with the name, server name. So it's going to take this server name and put it in there, get its ID, then use that ID to call this and return the result. So this is a little more complicated of a prompt, but it's basically saying when they call this tool with this parameter, run this prompt and use whatever tools, rules, and references you need to solve that problem. So one of the things we can do is we can actually test right from here. So you can edit these and play around with them. And what this is going to do is just going to launch an interactive chat session. So it's showing me what the prompt is going to send. It doesn't have any parameters, and I'll test in chat. So it's going to create a chat session, which just takes that exact prompt that it will run through the tool. It'll take a little bit of time, particularly the first time. And we'll see what it did. So in this particular case, he has to check the platform-specific configuration file, so it sees what directories you can access. It reads the text file, and then it has to go fetch the data at the endpoint, and it says, hey, I'm going to go see if I can talk to it at this thing I parsed out of the file, and then it takes the answer it got back, so you can dig in and look at actually what's going on, and all these tool calls, and then this is your final status summary. So this is what would be returned from the tool. So this is pretty impressive. This is a lot more than just yes, no. I didn't write any code. I just basically told it in English, how to go figure out if the server's running and what APIs to call. And it figured out, hey, it's running. The API port is here. The base URL is there. The gateway status is that it's the gateway, which is sort of a separate port, is also running. It's on a different port. That's the mode that it's in. And then I've got a little summary here. So that was pretty decent. So that's what that tool does. And let's close that back down. And then let's go look at one a little more complicated. So let's say we want to test this get server info tool. And we want to ask it about a tool called file system. And so what you can see is that as I type file system in, it replaced that token over here with the name file system. So again, I can see the exact prompt that it's going to send to the model. So I can do test in chat and it'll do the same thing. So I can, here it is, determine if ToolVault is running on what port. That's the prompt that's defined as part of this tool. This will also take a second, and this could be a little more efficient because it has to actually go figure out if ToolVault's actually installed and running and on what port before it can call these endpoints. So it has to sort of do everything we did in the last tool plus some other stuff. So there are ways we could make that more efficient, obviously. So here we go. So sort of see a similar thing, list a lot of directories, read. So this is the same stuff it did the first time to figure out if ToolVault is actually running, and then it called the API endpoints. I had to call it a couple times because it has a limit on how much data it can read, and then it found it. So it says, hey, ToolVault status, ToolVault's running. Here I found the file system server that you asked about. Here's its ID, its information. Here's how it's configured. So kind of over-delivered on what I asked it for. But again, it gave me all the information. And then finally a summary file server. The file system server is connected and operational, provides access to files in this directory. So that's exactly what I wanted. So now I have an agent that has two tools it exports that do pretty specific things to that agent. These are, like I said, these are not a lot of rocket science, and I can certainly imagine building, I did imagine building significantly more sophisticated, complicated, more rules and references, more tools, agents that are a lot smarter, but this is just to keep the example, simple and understandable. We have some pretty simple tools, but these can do, any amount of complexity, and we're basically masking the calling agent or something like Claude Code from having to understand all those details or how to go figure them out every time by just building this functionality into our own sub-agent. So how would we actually go install this? Let's see. It looks like this. So it's pretty straightforward. There's a bunch of different ways. We're going to demo this in Claude Code. This would work in any client or agent that talks MCP, and you install it just like any other MCP server, and the config is very straightforward. We're going to run this through NPX. There's a bunch of ways you could run it, but we're going to run NPX. This is the TsAgent Meta-MCP. This is the MCP server we're going to run, and it takes one parameter, which is a path to the agent. So this tvault is the agent that we just demoed that has those two exported functions. So that's all there is to it. Okay, we're going to run Claude and see if those tools show up. So this is Claude Code. Let's do MCP. And we'll see that we have there is our Meta-MCP server connected. We can enter to view details. We can see that it's connected, how it's configured. We can view the tools. We can say that it has the ToolVault status and the get server info. So these are the two tools that we built in our agent. So now we have connected Claude Code up to our agent. And let's just ask it a question. Let's say, is ToolVault running? So this is a question it probably wouldn't know how to answer otherwise. Okay, so we got a pretty short answer back, but it basically said, yes, ToolVault is running. The API server is running on this port. The MCP gateway is running here. Both services are operational and ready to handle requests. And if we wanted to pop into this, we'd be able to see, if we do Control-O, we can actually see what it got back. So that's when it called the Meta-MCP ToolVault status, this is the answer it got back. So pretty similar to what we did when we tested in the API, and then it basically summarized it down to that. Let's ask it another one. Let's say, tell me about the MCP server. So we can now see that it's going to call get server info, which is the other function we defined, and it's going to pass a server name parameter file system. So that's what it's doing here. Now I've got its answer back. It's going to chunk on that for a second. And this gave us back a cleaner answer than we got, honestly, from the agent. It parsed out what it got back from the agent. So it's not showing you all the intermediate work product of how it got to the answer, but it's saying, oh, great, you wanted to know about the file system, MCP server, and ToolVault. It provides file system access with the following config, server details, name, version, it's enabled and running, its server ID, its token, how it's configured, its status. This is actually kind of a cleaner version of it than the tool got back. So pretty straightforward, but what we've basically done is we've taken Claude Code that doesn't know anything about ToolVault, and we've given it a couple of skills as MCP tools to be able to get information about whether ToolVault's running and where, which it wouldn't have been able to easily determine on its own, and also to go investigate a specific server installed in ToolVault. And you can imagine this could be like a lot more complicated and a lot more functional. But we basically exposed our agent skills as MCP tools to Claude Code through MCP. Just, I think, kind of cool. So let's look at another example, just to show kind of a different way of thinking about this. So I was impressed by the MCP optimizer from StackLock, and also by similar functionality from, like I said, GitHub, Amazon, and Docker all did sort of similar things. And I thought, okay, that's kind of clever to because I have the same problem. We have semantic context inclusion within TsAgent, so I don't like fully have that exact problem, but I can definitely sympathize with people who are running MCP clients. They install 3 or 4 or 5 MCP servers, and all of a sudden they have 150 total tools that have 200K of context that they have to process on every single request just to be able to send the tool descriptions over to the agent, which is sort of silly. So this idea that like having the agent, having the client be able to say, hey, do you have a tool to do X? And then getting back a set of tools, a small set of tools, and then you pass that set of tools to the agent so that it can actually use the tools it needs, makes a lot more sense. So instead of processing 150 tools in every request, you're going to process more like 5 tools in every request. And the way that StackLock did it was pretty clever. They just basically have a find tool and a call tool function in their MCP server that sits in front of all the other MCP servers, and they implemented a semantic layer to do that. The Docker solution works almost exactly the same way. So I thought, well, it'd be interesting. Could I build something like that quickly with no code? And the answer is, yeah, I built this in about 10 minutes and it pretty much works. I'm not saying it works as good as those things and it's like a tested battle-ready solution that competes with them. I'm just saying like to sort of show that we can do something like that. And when we go to look at how this thing's configured, it doesn't have any references or rules, so it doesn't have any context. All it has is a set of tools. And it has the fetch tool, which is agent included. It has file system tools, which are all agent included. I've excluded this directory tree because it's sort of a mess. It creates way too much output, and I've never seen a case where anybody needs it, so we don't provide that particular tool. But all the rest of the file system tools we provide. This agent tag basically means that when the agent determines it's contextually relevant, we will provide that tool. And then we have our internal tools tool, which is Meta, and it has a bunch of tools that we're going to set to manual, which means we're not going to use these generally for this application, but it has search tools. So search tools is a tool that searches our tools for semantic similarity and returns the matching item. So it's a tool that basically takes a query string and you can give it some parameters about how you want it to match, and it will give you back a set of other tools that match that. So it's pretty straightforward. And this is all just built in. This is not anything that I've created for this demo. This is all just sort of built into how TsAgent does semantic context inclusion. But given that we have that functionality, we're able to go in here. And again, we have this MCP optimizer agent demo that's a tools exporting agent. And we go to exported tools. And we have 2 tools. And again, these are just tools that I built by just typing in this text in these prompts. So find tool says find and return tools from running servers. It can be accomplished at the user's request. Tells it how to discover tools. It takes a single parameter for the tool description, which is the task or capability that you need. And then the prompt template is call the tool search tools, which is the internal tool I just showed you, with the query value and then whatever that's provided, and return the tools found. So this is our find tool. And then we have call tool, execute a specified tool with provided parameters, use this function to return the tool, run a tool after identifying with find tool, execute it. It basically takes the tool name and the parameters and does a similar thing. It just says run the tool name with the parameters, if any, and return the result. So this is like a super trimmed down, skinny version of what you would do to do something like this in production for real, but this is pretty functional. And I can do something like I can test this and say, like, what if I wanted to test what directories can I see? So this is not going to tell me what directories I can see. This is going to give me a set of tools they would use to find out what directories I can see. So we'll do the test in chat, just like we did with the other one. And this is basically just going to take this built query for that skill or tool and run it in the agent with access to the context that it has available. And it basically comes back and says, hey, I have 5 tools that might be relevant to that. List allowed directories with the highest score is the one you're actually going to use. But, list directory, directory tree, list directory sizes, search files, these are all things that might be sort of relevant to that question. So anyway, so we can sort of see that this works. And to see that it actually works, we'll go see if we can come up with an actual demo. Yeah, we're going to do it here. So, all right, so we have Meta-MCP again, and this is in a different directory, so it has a different configuration that points to a different agent, but it has a set of tools, and those tools are find tool and call tool. So this is our optimizer agent. Okay, so what would we do with that? So let's say I'm going to do a predefined query that I know works. So we're going to say using MCP tools, determine what directories I can access. So what should happen is it should call the find tools with some description that it thinks has to do with accessing directories. So it did. It's called Meta-MCP with find tool, and the tool description is list directories, browse file system, access directories. So it sort of converted this into that set of capabilities. And it got back the top 5 matching tools. And now what we hope happens is it's actually going to call the tool. So one of the tools it got back was list of all directories. So now it's going to call that tool. I got back an answer. And here's what we have. You have access to the following directories through MCP tools. I have access to the tool vault directory and also to this application support tool vault directory. All subdirectories are accessible. And you can use the following tools within those directories. So Claude didn't have any access to get to the file system or to understand any of those tools. It just called the MCP server and said, hey, do you have any tools? And for figuring out about directories and files, the MCP server did a semantic indexed search to return the top 5 closest matching ones. Claude Code looked at those 5, picked the one that it liked the best, and used that. Again, use the agent tool to call that internal MCP tool. So Claude's not calling these MCP tools directly. It's calling it all through the Meta-MCP find tool call tool. So it's not like a super impressive demo, but the general idea is that we're able to take something like what some of these other products do, and in literally 10 minutes with no code, build something that works essentially the same way. That you can take an agent, build a skill that uses some semantic search, expose that via exported skills or tools into something like Claude Code via MCP, and have a working end-to-end solution where Claude Code is now talking to this agent that has some specialized knowledge or ability. So what does that all mean? We can build sophisticated, specialized, no-code agents with access to large libraries of rules, references, and tools. So basically what we could always do, we can build these agents that are very highly capable. They have semantic tool inclusion or semantic context inclusion, so you can give it as many rules and references, as many tools as you want without having to worry about it, because it's going to be able to select the ones that are the most relevant to each prompt as it processes them. We can use those agents to implement specific functions, which we're going to export as tools, similar to the way that A-to-A agent skills work. So we can basically make a defined set of behavior that we want those agents to have and implement those as tools that are well structured and defined with names, descriptions, and parameters. We can test and tune those tools interactively, so we can basically verify that those tools do exactly what we want inside the agent framework before we ever hook them up to anything. And then when we're done, we can use Meta-MCP to deploy those agent tools to any environment that supports MCP. So now we have any MCP client environment can now talk to an agent, a specialized agent, via this tool interface. And it's pretty slick. I think there's a lot of cool things that people could build with this, and hopefully people will. And if you build something cool, let me know. Thanks.